Hi everyone and welcome to this my video on the VCAA NHT 2024 General Mathematics Paper 2 Solutions, which would have been much easier if I just read it off there. My name is Darren from Maths Guru. Thank you so much for joining. Hopefully this video is going to be insightful. Some really interesting questions in here. Before I get going, if you can do me a massive favor and subscribing to my YouTube channel and of course liking this video, it really does do me a massive favor. Very few people watch maths videos, and the fact that you click subscribe just sends a message out there saying, hey, I watched your video and it was useful, right? It's really doing me a favor. It's sort of making me feel a little bit good about myself. Otherwise, I just sit here and talk to myself and slowly go mad. So if you can do that, that would be immense. And obviously share this video so that people around the world, and particularly in Victoria, know that it is there. Right, so this was 1 hour and 30 minutes and 15 minutes reading time. Oh, hopefully it's not going to take me too long to get through it. Data analysis. Data was collected to investigate the behaviour of tides in Sydney Harbour. There are usually 2 high tides and 2 low tides each day. The variables in this study were day, the day number in the sample, LLT, and HHT. Table 1 displays the sample of data collected from 14 places. There we go. That's my 14 pieces of information. For the HHT values. Now, I have been tricked so many times with this in past. I'm actually going to highlight that column because I don't want to make a mistake and put the wrong values in. Calculate the mean in meters. Round your answer correct to 1 decimal place. Again, I highlight left, right, and center. Why? Because I don't want to make a stupid mistake, right? And VCAA will knock you marks off. So I've got to put that data in and work out, what does it say, the mean in meters. Now, the good news is I've already got my data entered in. And for those of you who are using the Casio ClassPad, I am so sorry, guys. The functionality for this whole paper is pretty much the same as you have on your calculator. Hopefully, you'll just be able to translate it. Now, what you can see here is I have my titles as LLT and HHT. Don't make them something like Bob and Fred. It doesn't make any sense. And then my data values. Now, whenever I put these data values in, I always make sure that I've got the right number, and it said there were 14. And I do a quick scan up and down to make sure that all of the values are right, because there's nothing worse than making a silly mistake. What do I want? I want the mean, so I'm going to go menu, statistics, stat calculations, 1 variable statistics. Yes, I've got 1 list. My X list, I've got to remember, is HHT because it wants my HHT. And I'm going to hit enter. And then I'm going to read off the value of my mean. Now, again, it's just a 1 decimal place, which I'm going to get as 1.6. So if I write 1, he says in highlighter, let's get to my pen. If I write here 1.6, I am 98% sure that's going to be my correct answer. And it's been quite strange because normally VCAA questions always start with this: how many of these are numerical, how many of these are categorical? And they haven't done it this time. So part 2 of the question went on to say, calculate the standard deviation in meters. Now, again, standard deviation in meters, we've got to work out that there is basically this one here, which is SX. It wants it rounded to 3 decimal places. And so if I round that to 3 decimal places, I get 0.185. So my answer there is 0.185. And again, I'm 98% sure that's going to be right. Let's turn off my calculator so we can get to the next one. Use the HHT data from table 1 to construct a box plot on the grid below. So we got a box plot on the grid below. What do we need to know for a box plot? Well, basically the great thing about this as well is there is my 5-number summary. I've got min, Q1, median, Q2, and max. Now, again, I've got to be very careful here to make sure that my scale is correct and that I use a pencil. Please, guys, use a pencil, because if you make a mistake, then ultimately you're going to end up being able to rub it out. So we want 1.42 as my minimum. So there we go. There is 1.42. And again, when I did this originally, I stupidly did it there and then realized pretty quickly that they weren't going up in 1. So there's 1.42. That's actually my minimum. And my median is going to be 1.55. And again, I've got to be careful here because it's got to be smack bang in the middle. Now, you can do this way more accurately than I can because I'm using electricity. My max is going to be 1.92. All right, so my max is going to be 1.92, and I'm going to do a dot there or a little line. I don't see how it matters. What else do I need? I need my upper quartile as 1.74. So 1.74 is going to be here. And ultimately, connect those with a straight line. And connect those with a straight line. And again, it's going to be much easier for you to do than me because you've got pencils and rulers. And finally, connect a line along here, like so. And ka-ching, there we go. That is my box plot. And I'm just checking that I got the right thing here. Now, I tend to tell my guys, just so that it's clear for the examiner, that that is 1.42, 1.55, 1.74, and 1.92. Now, again, is that required by VCAA? I don't think it's going to hurt, to be perfectly honest with you. And it also says to the examiner, hey, I've done my points in the right place. Yep, just making sure that's correct. Right, the 5-number summary of the LLT data is shown in Table 2 below. Okay, thank you. Show that the minimum LL2 value of 0.92 is not an outlier. Now, this has got 2 marks. So you've got to do 2 things. You've got to show a calculation for my lower fence and then a qualifying statement. And lots of people always forget the qualifying statement. You have got to say whether it is or is not an outlier and the reasons why. So my minimum fence, if you remember, is given by Q1 minus 1.5 times my IQR. So this is my working out. So there's my, what I'm going to say, oops, I can't make that equals. So I now know that my Q1 is 0.39 minus 1.5 times my IQR. And if you remember, your IQR is Q3 minus Q1. And again, I'm going to write this in as 0.65 minus 0.39. So that's my minimum fence. Now, when I put that into my calculator, and I'm not going to, bore you with the calculator instructions, actually that comes out to be 0. So as far as I'm concerned, that would be 1 mark for your minimum fence. Therefore, you would say as 0.22 is greater than 0, okay, because obviously it's got, if it was less than 0, it would be an outlier, but as 0.22 is greater than 0, it's not an outlier. And again, the number of people who seem to forget to put that is actually quite staggering. A least squares line can be used to model the association between LLT and HHT. In this model, HHT is the response variable. Okay, use the data from table 1 to determine the equation of the least squares line. Well, that's lovely. I've already got my information here. Oop, he says, I've already got my information in here. So what do I do now? Well, I'm going to do doc, I'm going to insert, I'm going to do a data and statistics. It has told me that HHT is the response. So that goes on there. We've got LLT down here. Beautiful. And basically, now menu, analyze, regression, show line A plus BX. And there we go. Now you notice I always move this because it has had time before when this plus and minus, which you can see me circling here, has got hidden by one of the data points and people have lost marks. Right, now you'll notice I've got 4 boxes in which to fill in. So we've got the HHT. So I'm now going to write HHT in here, making it nice and clear. Does it say what we've got to round it to? Yes, it says round the intercept and the slope to 4 significant figures. Right, and again, if you don't know how to round to significant figures, please, please, please learn. It seems so silly to lose a mark for something you can learn. Right, so we've got 2.130. So I'm going to have 2.130, and that 0 is significant. You've got to put it in. Now it says plus minus. And again, people will get tricked here. You've got to write the minus inside, round that to 4 sig figs, gives me 1.054. So it's minus 1.054 times LLT. And there we go. As far as I'm concerned, he says turning that off, you'll end up with, I think, the 2 marks for that. Okay, how they'll give the 2 marks, I can't really tell you because I don't actually work for VCAA. I don't have any prior knowledge. I don't see the mark scheme. As far as I'm concerned, I believe this is my best interpretation at suggested solutions. And thanks, VCAA, for sort of allowing me to post them. Question 2. In the year 2021, there were 12 days when a new moon appeared in Sydney Harbour. Okay, for the 12 days, the occurrence of the highest tides, HHT, and the lowest low tides, LLT, occurred before, on, or after the appearance of the new moon. Sorry about the rustling. These records are displayed in the table below. Okay, thank you very much. Use the data from table 3 to complete the following frequency table. All right, so LLT before, and again, what I did was I highlighted 1, 2, so it was just 2. So LLT before was 2. HHT before, 1, 2, 3. There we go. So 3. Thank you very much. What have we got? We've got on. So I've got 1, just 1 for on. And what have I got for on? I've got 1, 2, 3 for HHT. And then let's see, we got after is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. And I always count these. I know some people say, well, you could just take them away on the table, but I don't because I don't trust myself. 1, 2, 3, 4, 5, and 6. All right, so there we go. Those are my 6. A final check to make sure I've got these right would be basically to add 2, 1, and 9. Does give me 12. 3, 3, and 6 gives me 12. I haven't made a mistake. Okay, cool. Part B, what's that? 2 marks. I would imagine if I was going to hazard a guess, 1 mark for all those numbers correct and 1 mark for those correct. Does the data in Table 4 support the contention that the occurrence of the LLTs is associated with the appearance of the new moon? OMG. Now, this is very different from what we've seen before. Normally, we've had a table and you've got to go across the rows or across the columns. But no, this was a bit of a spanner in the works. And when I first saw this paper, I was like, and I left it. But it's talking about LLTs. And so in the same way, we're just going to consider that data. The important thing here is by basically saying by comparing the values of appropriate percentages. We don't have percentages at the moment. And so I then went away and converted these into percentages. So if we look at the before, that's 2 out of 12 times 100. That's what I would do on my calculator. And to the nearest whole number, that works out to be 17%. In the same way, if I did 1 divided by 12 times 100, that will give me 8%. And that one there would be giving me 75%, which is just 9 divided by 12 times 100. Okay, and if you don't know how to work out percentages, please learn how to do percentages. It's terrifying the number of people who don't. Explain your conclusion by comparing the values of appropriate statistics. Okay. Now, obviously, you haven't seen me write this, but this is what I believe I would be putting as an answer. Yes, it does support the contention. It's 2 marks. You've got to answer the question, right? Explain your conclusion. Does the table support the contention? So yes, it does. As 17% are before, 8% are on, and 75% are after the new moon. So I've used appropriate statistics, and I've said showing on average an increase, all right? Because that's what we were looking at showing. So I imagine something like that would be okay as an answer. Moving on to question 3, the time difference between successive high tides and low tides is approximately normally distributed. Now again, whenever I see approximately normally distributed, I think to myself, okie dokie, I'm going to end up with my bell curve. So I'm going to draw a bell curve. To be fair, I haven't read the rest of the question, and I could be barking up the wrong tree. Ruff, ruff. Yep, I can't believe I did that myself either. 1, 2, and 3. Okay, so analysis of the 2021 tide chart showed that 99.85% of the time differences are more than 4.88. Now, again, I'm going to turn around and say to you here, I made a bit of a mistake when I did this question, because I saw 99.85%, and I was like, oh, that's going to be here. So I'm like, okay, well, that's fair enough. I'm just going to write my 4.88 there. And then it went 16% of the time differences are less than, what? 16% are less. Well, 16% being less is basically this section here. Yes, sorry, it's actually this section here, including there, because that's 34%. And I was like, hold on a moment, because when I go back and now write my answer on of, what did it say, 5.76, no, because how on earth can 4.88 be further down the scale than 5.76? And I realized very quickly that I'd made a silly mistake, or at least VCAA had maybe tried to trick me, because what it says is 99.85% of the time differences are more than 4.88. So what they're actually saying to me is that line there and above is basically more than 4.88. Now, doing that, all right, I now have my information. It says use the 68, 95, 99.7% rule to determine the mean and standard deviation for this distribution. Right, well, okay. Well, I now know that the gap between here and here is basically 2 sections. So if I now do 5.78 minus 4.88, I get 0.88. So that's 2 gaps worth. And so if I now divide that by 2, I get 0.44 as my standard deviation. And I wonder how many people would have written it in here, because it's the first thing you work out. And again, I wonder if part of the trick is to put the box over there. Maybe that's just me overcomplicating things. How do I get to my mean? Well, my mean is here. That's 1 standard deviation on top of that. So if I was to do 5.78 plus, what would I have? 0.44, I get the value of 6.2. And again, all of that could be done on your calculator. Again, a fairly nice question for 2 marks. I would imagine 1 mark for each of those correct answers. In another study, the height in meters of the highest tide HHT for that day and the lowest low tide LLT for that day were recorded in Sydney Harbour for the 31 days of July the 21st. Okay, of July 2021, sorry. A scatter plot of this data is shown. There it is. How beautiful. Love it. When a least squares line is fitted to the scatter plot, the equation is found to be that one there. I have a feeling I know what they're going to ask me to do. The coefficient of determination is that. Now, again, I always write down r squared there because I don't want to get confused. Draw the graph of the least squares line on the scatter plot above. Right. Now, I'm going to run out of space. But what I know is, and this is such a standard question, and it always worries me and upsets me a little bit when people lose this mark quite needlessly. The lowest value on my scale is 0.2 and the highest scale is 0.64. So almost formulaically, I put 0.2 into here and I work out what my HHT is, and I put 0.64 into here and I work out my HHT. Now when I do that, and again, I've already worked this out, when I put in 0.2, I get, he says, losing 1.974. And when I put in 0.64, I get 1.4988. Now, those values may be rounded, but that's okay. These are now actual coordinates. These are coordinates that sit on that least squares line. And these are coordinates I can plot on this graph. That's the trick to doing these questions. It is always the lowest value here, the lowest value here, put it into your least squares regression line, plot the points, and then using a ruler, please don't ever freehand this, but using a ruler, join them together. Now, while I'm on about this, you can do me a favor and subscribing to my YouTube channel. That would be so awesome. Just click subscribe, hit like on the video as well. It just lets me know that people watching the video. So very few people watch maths videos. If you can click this, it just makes me feel like basically to continue doing it. Otherwise I get a little bit like, oh, I can't do this anymore. No one's watching my content. Right, so I've got 0.2 and 1.974. So again, I've got to be pretty accurate here. That's going to be 0.8. So it's going to be just below there. So there we go. I'm going to put my cross there. And at 0.64 is 1.498, so 1.5. So again, try and find my 1.5, he says. And I believe that is there. Yep. And again, all I need to do now, and it's great because my pen does this quite beautifully for me, is join those two together. And VCAA do absolutely check that these points here are in the right places and that you have used a straight line to join them together. All right, so that's 1 mark. Determine the value of the correlation coefficient R. Now, that's okay because they've told me that R squared is equal to 0.4709. I'm going to bring my CAS up in this situation because it's a bit of a trick. I'm going to go doc, insert, and calculator. Now, if we know that R squared is that, I now know I can square root, what is it, 0.4709 and hit enter. And because your calculator is a dumb piece of machinery, it's going to tell you that basically R then is equal to 0.686221, and so we go on. Now, I don't know how many people are going to write that down as the right answer, but it is wrong because when you square root something, in fact, there are 2 values. There is both the positive and the negative, and on the whole, your calculator will only show you the positive. Now, the difference to that is if you actually go menu, algebra, solve. He says, SOLVE, open a set of brackets, R squared equals 0. Hold on, bear with me. R squared equals 0.4709, comma, R, and hit enter. Now, there we go. By doing it that way, your calculator is saying, well, actually, there are 2 values. And I really wish there was some way that TI and Spark could tell you, hey, actually, there are 2 values. Because now we have to look back at the graph. Because there is no way that that graph can have a positive value of R. Because it's sloping down. And in which case, that means that the correct answer for this would be that R is equal to minus 0.686. How do I know it's 686? because again, my question says round to 3 decimal places. Notice how many times rounding to significant figures or decimal places has come up. Describe the association between HHT and LLT in terms of form and direction. This is just summary book stuff. I really like this question because I was like, well, there's nothing too particularly complicated in here. The form, you've got a choice of linear or non-linear, and it is definitely, in this situation, suggested it's linear. And the direction, positive or negative. And again, in that situation, we would say negative. Interpret the slope of the least squares line in terms of the variables HHT and LLT. Again, a standard question that has a boilerplate response that basically says, on average, comma, for 1 unit increase in my explanatory variable, there is a, increase in or decrease in. So I'm going to write that out now. And so there we go. So let's just work out what is. So we got to start with on average. Again, just write it. For every 1 meter increase. Now, how on earth do I know that it's 1 meter? Because my LLT is given in meters and the increase is always 1. Not decimals. Don't worry about decimals. That is always 1. So for every 1 meter increase in LLT, there is an 1.08 meter decrease. Where do we get that from? It is here. Minus is the decrease, 1.08. And again, how do we know the units? Because HHT is measured in meters. So all of that there is required for the 1 mark. The on average, 1 meter increase in LLT, there is a 1.08 meter decrease in HHT, all of that for 1 mark. Now, in this investigation, the HHT value was 1.81 for an LLT value of 0.40. Show that when this least squares line is fitted to the scatter plot, the residual for the point is 0.042. Okay, so residual. Automatically, I wrote down here that the residual is equal to my actual value minus my predicted value. Now, the actual value they've given me, all right, they actually have given me as 1.81. And when I did this initially, I was like, oh, that is a bit weird. I didn't pick up on that. I actually used the 0.052. But again, it just didn't make any sense. And actually, they've told you what the answer is. So what they're really asking here for you to gain those 2 marks is your working out. You've got to show the working out. Minus my predicted. Well, where do I get my predicted from? Well, lo and behold, we get it from here. We know that the equation for my predicted HHT is given by that, 2.19 minus 1.08 times LLT. So again, what I did was I said in brackets 2.19 minus 1.08 times my LLT, which they gave in the question as 0.4. All of that on one line was fine. That gave me 0.052, ka-ching. There we go. That would be my 2 marks. I would imagine they'd be looking for that 1.81. They'd be looking for that formula. They'd want it subtracted and that to give you your 2 marks. The mean value of the HHT values for July 2021 is 1.7. Calculate the mean value of the LLT. Now, again, I looked at this and went, huh? But again, it is just a trick. It doesn't matter whether it's a mean value or an actual value or one specific value. This formula holds true. The mean HHT is given by 2.109 minus 1.08 times the mean LLT. Ah, okay then. So, but again, they're trying to, I use the word trick you because we know that HHT is equal to let's try that one again, 2.19 minus 1.08 times LLT. What have they given me in the question? Well, they've given me the HHT. So in this situation, it's 1.70 equals 2.19 minus 1.08 times my LLT. How did I work that out? Slammed it into my calculator with a solve function. Am I going to show you how to do that? No, because I'm hoping you can do that. And what we found out then was the LLT came out to be 0.45. And obviously that would be meters, but anyway, 0.45. 1 mark for that calculation. Question number 5. The height in meters of the maximum high tides for Sydney Harbour changed from month to month during the year. Now, this is shown in the time series plot below for the years 2021, 2022, and 2023. In the graph, month number 1 is January 2021, month number 2 is February 2021, and so on. Okay, so there's my graph. The average height in meters of the maximum HHT for each year rounded to 2 decimal places is given in the table below. Okay, so these are my averages. Where do I see the word average? The 3 years of data shown in this graph and in table 5 will be used to calculate, there you go, seasonal indices. Determine the seasonal index for March. Now again, I sat and looked at this for a little while and went, determine the seasonal index for March. And round your answer to 2 decimal place. March? Well, as it turns out, what do we know? We know that the seasonal index is given by my actual divided by my average. Okay, so my seasonal index for March is going to be given by my actual value for March divided by my average across that year. Do we have all of that information? I should Coco. So, therefore, for 2021, I know that my seasonal index, therefore, is going to be equal to my actual value for March 2021. So if I look at this, that's going to be what? January, February, March 2021. I read that value off, I get 1.89. All right, so I now know then my seasonal index is going to be 1.89 divided by the actual, or the average height is 1.98. For 2022, my seasonal index is going to be March 2022. How do I find that? Well, I can basically add 12 months onto that, or just add 12 onto that, which gives me 15. So if I now highlight my value at 15, he says trying to rub it out. There you go. That's my number at 15. And read across. He says trying really hard to see that. That's 1.92. So my March for that one is 1.92 divided by 1.99. And for 2023, I think it is, my seasonal index, well, firstly, that's going to be divided by 1.96. And I want my 2023 value. So I'm going to add 12 onto 15, which gives me 27, which is that value there. Trying to read across. It's going to give me 1.93. Okay, so that's 1.93. Now, because it wants the seasonal index for March, it means I've got to work out those individuals and then add them together. Right, so let's see if I can do this without messing up my calculator. So let's do divide. 1.89 divided by 1.98. I want to add to that, please. Again, 1.92 divided by 1.99. And I am going to add to that 1.93 divided by 1.96. Hit enter. Divide that by 3 because I want the average. Is going to give me 0.968. What rounding do we need to 2 decimal places? Therefore, my seasonal index for March is going to be equal to 0.97. Okay. Now, again, if you rounded these early and didn't use these actual calculations, what I'm finding out is, and I did this earlier, you actually get a rounding error. You get 0.98. So don't round until the very, very end. The next question I really, really liked. I've never seen anything like this before, but really liked it. The time series plot below shows the heights in meters of the highest high tide, HHT, and the lowest low tides for Sydney for the first 60 days. The thick line for each tide type shows the results of smoothing. Oh, interesting. Smoothing using a moving median. Oh, okay. Right, so complete the sentence below by entering a number in the box provided. Both the HHT and LLT data will be smoothed using what median smoothing? Well, the way I did this, believe it or not, and I can zoom in for this moment in time, is I'm like, well, okay, if I look at this point here, right, that is sitting there. And so, because I've got no data items beforehand, it means that all of those were used to create that point. So I've got 1, 2, 3, 4, 5, 6, 7. Including this point here, I've got to have 7 on the other side. 1, 2, 3, 4, 5, 6, 7. 7 plus 7 is 14 plus 1. It gives me 15. And so basically, what we can say, and again, this is a very interesting question, is that that was smooth using 15 median smoothing. Love, love, love. Very clever. And there we go. That was the end of data and statistics. Then we moved on to finance. And again, the finance section of this paper, I don't think was overly complicated. It was relatively straightforward. When we got to matrices, that was a whole new discussion, but we'll come to that in just a moment after I've had a cup of tea. Now, if you are watching this part of the video, and thank you if you are, if you can subscribe, that would be great. I say it over and over again. So very few people watch maths content, and people keep saying to me, your videos are great, and they are. There's mathsguru.com. There is a downloadable summary book. If you have not got a summary book sorted for the exam coming up, then it is there. If you are about to prepare for an exam, it is over there. But if you can click subscribe, it just shows me that you've watched, basically. And if you click like, that would be awesome as well. Okay, question 7. Cleo took out a reducing balance loan to buy an apartment. Interest on this loan is charged monthly. All right, let's work that one through. Monthly. And the loan is scheduled to be paid in full after 20 years. The balance in Cleo's loan in dollars after n months can be modeled by the foreign recurrence relationship. What amount in dollars did Cleo borrow? Well, that's got to be my C0. So I've got 560,000, and I'm going to put the dollar sign in front. Never really understood why people put the dollar sign at the end. Anyway, determine the total value in dollars of the repayments made by Cleo in the first year. Well, we know that she is paying $4,012 every single month. So we now know that's going to be $4,012. There are 12 months in a year. And again, I'm not going to bring my calculator up for that. But if I do a dollar sign, it's going to be $48,144. Cool. The interest rate for Cleo's loan is 6% per annum. Use this value in a calculation to show that the multiplication factor in the recurrent relationship is 1.005. I tend to do this. I take the 6 and I divide it by 100. That gives me a decimal percentage. That's going to be per annum, but I want per month. So then I'm going to divide that value by 12. And then I'm going to add on the number 1. Now, there are lots of ways of showing this, but it does actually say that you've got to show that. You can't just sort of reverse engineer. A lot of people try and take the 1.005 and turn it back into 6. You can't. You have to take the 6 and turn it into 1.005. And as far as I'm concerned, showing that is equal to 1.005. And obviously, do check it on your calculator. We are good. Complete the next line in the amortization table. Write your answers in the spaces provided in the table or in the table below. Okay, so first things first, we know now that this value here is my opening balance. My repayment is going to be $4,012. Again, we are just getting this from that value here at the top. Okay, we know our line interest rate is going to be 1.005, which means I can now get this value here by multiplying 560,000 by 1.005. And again, for the brevity of this video, I'm going to tell you that when you put that into your calculator, you get 2,800. Our principal reduction is going to be the difference between those two subtracted. And again, when I teach my boys this, I actually make sure that they put copies in their summary books to make sure that they've got all, because these are the questions that tend to trip people up. So when I do 4012 minus 2,800, I get 1212. That's my principal reduction. And bearing in mind, I've got 560,000 and I'm reducing it by 1,212. If I take those away, I get 558,788. There we go. That's my line. And again, 1 mark for all of those. Yes. The final monthly repayment required to fully repay the loan to the nearest cent will be slightly higher than all the previous payments. Determine the value of this final repayment. Well, as far as I'm concerned, the easiest way to do that, he says, moving his cuppity, is to fire up my calculator and go, menu, where are you? There you go, menu, finance, financial solver. Right, so the final monthly repayment required is, we know that it's going to take 20 years at 12 months. Oops, he says 12 months. My interest rate, they said, was 6. My principal value, because was it a loan or investment? It's a loan. So it's going to be 560,000. We know the payments are going to be minus 4012. My future value, we are going to find out in just a moment. The reason I'm going to find the future value in a moment is because that's going to tell me how much I have left at the end of the loan after those 240 payments. And when I hit enter, out comes minus 6.44. That minus means I still owe money. So I've got to pay, or Cleo's last payment is going to be 4012, and we've got to add on that $6.44 to clear my loan down. And putting that together gives me a grand total of 4018.44. And I believe that is going to be my correct answer. Again, pretty standard questions here. Cleo owns equipment that was purchased for $50,000. She depreciates the value of the equipment using the unit cost method. And understanding the difference between all of these, flat rate depreciation, and unit cost and reducing balance is really, really important. Let Vn be the value of the equipment in dollars after K units of use. A occurrence relation that can model this value from one unit of use to the next is given by, what does K represent in this recurrence relationship? And again, to save you watching me, there we go. The amount by which the equipment loses each use or devalues each use, something that says basically the amount it's losing each use. All right, so that's what unit cost method means. If K is equal to 12.5, determine the value of the equipment after 1 year. Okay, if it is used twice per day on all 365 days. Okay, so we now know it's going to be used for 365 days twice on each day. So what I did was do 365 times by 2. And I'm going to multiply that by 12.50. The reason being is I'm using it twice a day, all year, and every single one of those uses cost me $12.50. Put that into my calculator, and what I got was $9,125. And I thought that's where I was going to leave the answer, but it says determine the value of the equipment after 1 year. Well, we started off with the equipment being 50,000. I'm going to take away that 9,125, which tells me that my equipment will be $40,875. Now, another option for Clio is to depreciate the value of the 50,000 equipment using the reducing balance method. And again, a lot of people don't understand the difference between that, right? This is where we have the multiplier. And luckily, in this situation, they've given you that. The value of the equipment in dollars after n months, and again, it's always important, can be modeled by the recurrence relation of that form. If the depreciation rate per month was 1.5%, right, if the depreciation rate was 1.5% a month, what would be the value of R in this recurrence relationship? Now, again, it's given it per month. Normally, we give it per annum, but it didn't. So what I'm actually going to do is I'm going to do 1.5 divided by 100, and I'm going to do 1 minus that, okay? Why? Because if it's depreciating, it's 1 minus that interest rate, that line interest rate divided by 100, because 1.5 is a percentage. We divide by 100 to get it into a decimal, and then we do 1 minus that. So when again, I put that into my calculator, I got 0.985. Whew. For what value of R would the equipment be valued at that after 3 months? Well, what they're actually giving you there is a final value. So they're giving me my final value. I know my initial value, and I know that my recurrence relationship, if I wanted to write it in another way, would be V of n equals R to the power of n times V0. This is the rule, all right? At the moment, this is a recurrence relationship, which I could do it line by line and repeat it, but actually it probably makes life easier to be a rule. So I now know that the equipment was 42868.75. That's my VM. My rate is going to be R. I know it's over 3 months, so I can raise that to cubed. And then my V0 gives me $50,000. Again, put that into my calculator and do solve, and we get my capital R there as equal to 0.95. Right. So again, knowing the difference between a recurrence relation and how to turn that into a rule for reducing balance is really, really helpful. And it made this question probably a little bit quicker. Cleo took out a loan of $35,000 to pay for an over $35,000 to go on holiday. She could go to Geelong for much cheaper. Interest is charged at the rate of 10% per annum. I'm going to highlight that. Compounding quarterly. Aha. For the first year of the loan, Cleo made quarterly repayments of $1,722. Let Vn be the balance of Cleo's loan in dollars after n quarters. Write a recurrence relationship in terms of that can model from quarter to quarter. Well, okay then. Well, in which case we know that V0 is going to be 35,123, comma. Now, weirdly, normally they would be 2 marks. You get 1 mark for that and 1 mark for the next bit, but not this year. V of n plus 1 is equal to, now, I got 10% per annum, and I can't write that per annum because I've got to do it quarterly. So what I'm going to do 10 divided by 100. That's going to turn it into a decimal. I'm going to divide that by 4, which is going to give me a quarterly interest rate, and then I'm going to add 1 to that. Now, when I do that, I get 1.0 1.25 on my calculator. Again, I'm not going to show you the calculator just to keep this slightly smaller. That's going to be times V of n, and I'm going to take away from that 1722 because that's my monthly repayment. There we go, there's my 1 mark. For the second year of the loan, Cleo increases her quarterly repayments to $2,000. Determine the total amount of interest. This tricks people left, right, and center, and I mean it tricks people. Now, before I do the answer, I'm going to have a cup of tea, if that's okay. Very British. Been living in Australia for years, but still like the cup of tea at the end of the day. Now, if you can subscribe to my YouTube channel while I'm doing this, that'd be incredible. Just click that little button. It just says, hey, Darren, I've watched your video. Thanks very much. Yeah, click like. It tells YouTube it's actually valuable, and hopefully they'll push that out to other people. Otherwise, I'm sitting here talking to myself like a complete loser and loner, which probably both are true, but we'll move on. Determine the total amount of interest. Lots of people mess this up. If you think about the interest, it's about your loan is going to reduce. So if I, for example, as a sideline, took out $1,000 and for a year paid off, I don't know, or paid the bank $2,000. So my payments in total were $2,000. You'd expect my loan to go down to $8,000, wouldn't you? But the chances are it won't. If, so make that, was that 10,000, sorry. You'd expect it to go down to 8,000, but in fact it isn't. It may actually go down to 9,000. Why? Because of interest. So I can work out what interest has been made or paid because that's how much I paid the bank. That's how much it actually went down by, and the difference would be the interest. And that's the premise for pretty much this question here. So what I said was, well, let's look at year number 1. If we put the information into my calculator, I know she started with $350,000. That's her opening balance. But how much was left at the end of the year? Well, I can't do that in my head, but I can fire up my financial solver. So it told me that, does it say how long it's going to take to pay off? No, but it does tell me my repayments. Okay, so in which case, it's for the first year, she's made how many payments? Well, it's quarterly, so they're going to be 4 payments. Move my working out over and try and get my keyboard so I can actually write on it. So hit tab, much quicker. My interest rate, it said, was 10%. If I remember rightly, my principal value was 350,000. And what was it? Some of the interest of, was it a loan? Took out a loan, yeah. So 350, 123. We know the payment is going to be 1722. So I'm going to do minus 1722. Hit enter. Now, I've got to make sure that says 4. And that's 4. And there we go. So what I'm now going to say is my future value works out to be, I'm just checking my answers. Oh, let's go back to that again. That's actually 35,000. 3,500? No, 35,000. I thought that's what I just had. Hit enter. There we go. That's slightly better. I was a little bit worried there because my figures weren't matching up. So we now know, having done that correctly, that at the end of that year, she still owes 31482.819265. Right? So if I subtract those, that's going to tell me how much she's actually paid off the loan, all right? Or how much the loan has. Now I do that, and I get $3,517.18. I'm actually just going to check that because I'm beginning to realize I didn't write out all my working out properly. So 350. Let's get rid of one of those. 0. And I'm going to take away 31482.819265. And I'm going to keep those decimals in. Gives me, that's it. Now I'm going to round at this moment in time because I think that's going to work out, right? So that's basically what I've paid off, all right? But that's not what I paid the bank because, or Cleo paid the bank $1,722 per quarter. Now, when I do 1722 times by 4, she actually paid the bank 6888. Well, hold on a moment. She paid 6888, but only 3,000 was paid off. The difference was going to be the interest. Now, when I take those two away, I actually get 3370.82. So that's how much interest she paid in year 1. And guess what we do? We do the same thing for year 2. Now again, so in year 2, she's got an opening balance of 31482.819265. How much is she going to have at the end? All right. So I'm going to go menu, finance, financial solver. I'm going to copy that value. I'm going to do Control and C to copy, and I'm going to put it there. I do Control and V. Now, because I'm almost restarting the question, that's going to become positive. Now she says she pays off $2,000, so that's minus 2123. And again, the interest rate stays the same. Everything stays the same. How much has she got left? He says, clearing that out. Come on, play nicely. Financial solver. Yeah, if I didn't have so much on my desk, life would be so much easier. Right, so final value was 26446.1104, whatever. So how much, therefore, has she paid off? Well, if I now do escape, and I'm going to do 31482.819265, subtract from that 26446.1104, it tells me that $5,036.71 were paid off. But how much did she pay the bank? Well, it was $2,000, again times by 4, which I can do in my head, which was $8,000. So if I take those away, then therefore the interest in the second year worked out to be 2963.29. And so her total interest paid would be this value here plus that value there. All right, so there I'm going to write, therefore, total interest is equal to 6334.11, which when I add those two together is what I get. A lot of work in there for 2 marks, but that basically is the nature of the beast. So what have we got here? We've got matrices. If you haven't already subscribed to my YouTube channel and you would do that, it would mean the world to me. All right, I'm sitting here talking to myself like a complete loser, and just hitting that subscribe button says, Darren, I've watched your video. Thanks very much. All right. Otherwise, I could be in there watching, I don't know, Married at First Sight, eating chocolate. Right. An egg farmer has 5 barns on the property I, J, K, L, and M. Matrix H below shows the available communication links between the 5 barns. Okay, these type of questions, it's always important to know sender and receiver. 1 indicates what it does, 0 indicates, right, which barns can directly communicate to barn L. Okay, who can directly communicate to barn L? Well, I'm looking for, basically, the receiver is L. Who can send to that? It would be nice and simply K and M. Oh, loving it. State 2 communication paths from J to K. All right, then. So J to K. So J can go to M, and M can go directly to K. So there we go. So that's J to M to K. That's lovely. Okay. Well, here's the trick. Because J can talk to M, M can talk to L, because L can talk to K. There we go. So the second one, which was a little bit more tricky, I suppose, and you had to get both for the 1 mark, was J to M to L to K. The farmer plans to install 1 new direct communication link in 1 barn to receive direct communication from barn I. In which barn should the new direct communication link be installed to ensure that barn I has either a 1-step or a 2-step? Now, in this situation, the word was or, with every other barn. Now, the best way to do this actually was trial and error. There was no way that I can think of that would allow me to do this straight away. So what I did when I did this question was when H becomes equal to, and I defined H in my matrix. Oh, and it's not 4x4, it's 5x5. So I'm going to hit enter here and shift and enter there, and that's going to give me some new information there. Right. 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1, 0, 1, 0, 1, 1, 1, and 0. There we go. There's my H. Now, because I wanted to keep that, I went, well, then let G become equal to that as well. And the reason being is because what I'm going to do now is I'm going to change one of these, because we've got to add 1 communication link into into I. So I've got to add 1 communication link into, I've got to change one of these numbers for a 1. Well, I'm obviously not going to change that one, so it makes sense to try J first. So what I'm going to do is I'm going to basically copy that down and add a 1 here. Now, when I do G squared, that's basically my two-step communication link. And what we're trying to work out now is, will that create, and go back to the question, in which barn should the new direct communication link be installed to ensure that barn I has either a one or two-step communication link, which means that all of these values here for both G and G squared have to be 1. Well, as we can see here, nah, that's not it. So it can't be L. Right, what's my next one? Well, I'm going to go up and basically delete, delete, delete. I'm going to say let G become equal to that. And I'm going to now change this to a 1, not 21. 1, hit enter, G squared, hit enter. And let's look along that top. Is there a one-step communication for everything? Nap. I've got 1 there. I've got 2 ones there. Sorry, 1 or 2 step. Not there. So that's no good. It's not that one there. And to shortcut this process just a little bit, if I get rid of that, if I go G becomes equal to that, and I actually change M to 1 and do G squared, then what you will notice is, because obviously I isn't going to communicate with I, you've got to communicate with others. I've got a 1 here. I've got 1s everywhere else. So in fact, the correct answer here was M. Right? And again, I can't think of any other way of doing that other than trial and error. And it's just basically understanding what the question is looking for. Right, what's this one? A farmer sells 4 different egg sizes, medium, large, extra large, and jumbo in cartons containing 12 eggs. The table below shows the total egg weight in grams per carton for the different egg sizes. This information can be displayed in matrix E. All right. Complete the following matrix equation that will calculate the average egg weight in a carton for eggs of each size. Average egg weight. Oh, well, hold on a moment. We know that the total for those 12 eggs is 504. The total for those 12 eggs is 600. The total for extra large is that, and the total. Well, if I know how to work out a mean, I work out the total divided by how many eggs there are. So you could argue that you'd write divide by 12 here, but mathematically, sorry, not, because you actually got to write a matrix equation. So that would therefore be 1 on 12. And then when you put that into your calculator, and I'm not going to bore you with that, that gives you 42, 50, 58, and 67. All right, so there we go. 1 mark for both of those. On one day, the farmer sold 122 cartons of medium, 148 cartons of large, 80 cartons of extra large, and 52 cartons of jumbo eggs. Sheesh, a lot of eggs. In the space below, write a matrix calculation. You have got to write the matrix calculation using matrix Q and a column matrix to show that the total number of eggs is 4824. Right. For it to be Q, we've got to have here 122, 148, 80, and 52. Now that's a 1 by 4, which means we'd have to have a 4 by 1 in which to be able to multiply those together. And in fact, we do, because what we're now trying to work out is, sorry, in the space below, write a matrix calculation and a column matrix show the total number of eggs. All right, so because we know there are 12 eggs in each of these boxes, I simply need to multiply each of those numbers by 12. And again, 122 times 12, 148 times 12, 80 times 12, 52 times 12. And again, if you put that into your calculator, you do in fact get 4824 with a bracket. Now again, I would make sure that you've got your matrix calculation. You put a times in there, but I would make sure that you've got the initial, that one, and your answer shown in matrix form if you were going to get the mark. Well, cool. This page is blank, bit like my brain. 3 types of eggs are sold at a local supermarket: cage, free range, and barn laid eggs. Each week, customers purchase eggs from one of these 3 types. The supermarket is holding a 10-week campaign to encourage more shoppers to purchase free range eggs. Let SN be the state matrix that shows the expected proportion of customers who purchased each type of egg. The proportion of customers is that right? Okay, we've got a recurrence relationship. Okay, we've got a transition matrix. Okay, an incomplete transition matrix diagram for matrix T is shown below. Complete the transition diagram by adding the missing edges in the correct proportions. Now, trying to keep this all on is going to be really difficult, but CFB. So I'm writing under here C, F and B. Right, so C to C is 0.65. So the first thing I'm going to do is draw a circle on there, and I'm going to put 0.65. F to F is 0.7. So let's move that up for a moment. I get 0.7. 0.70, and B to B, again, reading from my diagram, gave me 0.45. And it is critically important for transition diagrams that you put on the arrows. All right, now, C to F, we've got this one here. There's got to be one. There's got to be one here. And that's got to go that way. And the reason it's got to go that way is the arrows have got to oppose each other. All right, so because that arrow is going that way, this one has to go that way. And ultimately, if I put that one there, that's got to be an arrow that way. Now, all we needed to do then was read off from the table C to F. So C to F was given as 0.20. So here, just 0.20. What have I got? B to C, which is this one here. So B to C gives me B to C 0.25. So 0.25. And ultimately, when we read off the diagram, that's 0.15. That was one mark, and you had to show all of that information on there. How many weeks after the campaign begins will more than 44%, right? More than 44% of the customers first be expected to purchase free-range eggs? Okay. So we've got our current relationship. Let's fire up my calculator and let's put in some information. So let's put in S0. And the great thing with the TI Inspire is you can actually do that. S0 becomes equal to, and what do we want? We want a 3 by 1, number of rows 3 by 1. Hit enter. And let's put in 0.4, 0.4, and 0.2. Hit that there. T becomes equal to. What do we got there? 3 by 3. That's nice and easy. Let's do that. So this is going to be 0.65, 0.15, 0.25, 0.2, 0.7, 0.3, 0.15, 0.15, and 0.45. Hit enter, and there we go. Now, I always check these because I've made mistakes before, and I don't want to do it again. 0.65, 0.15, 0.25, 0.2, 0.7, 0.3, 0.15, 0.15, and 0.45. Okie dokie. So it tells us to go from one state to the next, you'd pre-multiply S by T. So what I'm going to do now is I'm going to do S0, put that into my answer, and I'm going to do T times my answer and hit enter. So that's 1 week, and we are looking for 44%, more than 44% of the customers to be free-range eggs. Which number is free-range? It is the one in the middle. So I'm looking for that middle value to first become greater than 0.44. So that was 1, 2, 3, oh, so close, 4, and there we go, 5. So as far as I'm concerned, the correct answer to that would be 5 by using my calculator. During the duration of the 10-week campaign, 2,000 customers purchased eggs at this supermarket each week. Identify the expected number of additional shoppers who would purchase free-range eggs at the end of the campaign compared to the beginning of the campaign. Right, so first things first, let's try and work out what my value of the number of eggs, or what proportion of my eggs will actually be sold to free-range. And the way to do that is firing up my calculator again. He said, and I'm now going to do T to the power of 10, that tells me 10 weeks, times by S0. There we go. So we know that 0.44, 0.44280835 ... times by 2,000 people, because that's the start number of people who purchased eggs at the supermarket each week. All right, so that's 2,000 of those people will have got 886. So 886 people, right? But the question is, how many people bought it at the start? How many people would have bought it at the start? Well, we know the original proportion was given by 0.4. So if I do 0.4 times 2,000, because that's what it was in the first week, and I do, where's my calculator? 0.4 times 2,000 gives me 800. And so therefore, an extra 86 people will purchase free-range eggs after the 10-week campaign. The farmer believes that their free-range eggs are so superior that shoppers will eventually stop purchasing cage eggs and barn-laid eggs and only buy their free-range eggs. Okay, complete column F in the following transition matrix for a scenario in which shoppers will eventually stop buying cage eggs and barn-laid eggs and buy only free-range eggs. Cold tea. That's disgusting. Oh, please subscribe to my YouTube channel. It means the world to me. Well, okay, if they're not going to buy cage eggs, well, okay, they're not going to buy barn-laid eggs, and everyone's got to buy free range. That's simply the answer. And I thought that was way easier than lots of the other questions. Right. A farmer has 4 fields for chickens to roam in during the day. This question was quite challenging, particularly parts B and C, because it was an interpretation thing. And I have to say, the first time I did this, I was like, huh? But the fields are named north. So what have we got? 4 fields of chickens. North, east, south, and west. The following transition matrix is used to determine the expected proportion of chickens that will either change fields on one day to the next or stay in the same field on consecutive days. There were initially 10,000 chickens in each field. 40,000 chickens in total. Crazy. All right, after one day, how many chickens are expected to remain in the same field that they were initially? Nice and easy question. North to north is 30%, 28% east to east, 12% south to south, and 90% west to west. And because each of those had 10,000 in, I'd be looking at 10,000 times 0.3 plus 10,000 times 0.28, that's east, plus 10,000 times 0.12 plus 10,000 times 0.19. Now, when I put all that into my calculator, I get 8,900, which I'm fairly sure is the right answer for 1 mark. Now, this was the one that absolutely did my head in. After 2 days, 8962 chickens are expected to be in North Field. How many of these 8962 chickens are expected to have been in the North Field initially? Now, this word initially threw me completely. But when we unpacked it, and I say we and my great colleague at work, what it means was, all right, in the field were there initially. All right, so first things first, in the North Field, so if we look at the North Field, we started with 10,000 chickens. Yes? 30% of those stayed in the North Field after day 1, and another 30% stayed in the North Field. All right, so 30% of these stayed, and 30% of those stayed, because that's what our transition matrix said. Yes, that's what this field. That's what that means. 30% of chickens that started in North will stay in North. Right. So if I now do 10,000 times 0.3 times 0.3, I'm going to get 900. And some people will go, well, okay, that's fine because, well, we're done. Actually, no, we're not, because there were chickens that started in the North Field, went to the East Field, and then returned to the North Field. And I think this was the trick to the question. Very clever question, not necessarily, in my view, language-wise, great, because it tricked me completely. But what it's saying is there are going to be 10,000 chickens, so same 10,000 chickens. Some of them are going to start in the North Field. They're going to transfer to the East Field, but then transfer back to the North Field, which means they were effectively there at the start. They've just returned to the same field. Once you get your head around that, it's okay. So you've got 10,000 times by 0.14, because to go from North to East is 0.14, and then to go from East to North is 0.12. So basically, if I do that times 0.12, I ended up with 168. So 168 of the original chickens started at North, went to the East Field, and then came back to the North Field. Again, we're starting with those 10,000 chickens, went from North to South and back to North. So again, that'd be 10,000 times 0.24. The reason being is North to South was 0.24. But south to north. So 24% of my original chickens went to the South Field, but 30% of those came back to the North Field. So I'm going to times that by 0.3, which gives me 720. And again, north to west to north, 10,000 times by 0.32. Those north chickens went to the west, and of that, 20% came back to the original field, which gave 640. And when you add all those together, you get 2,428. And I'm 98% sure that that's the answer they're looking for. And that was hard work. Okay, and particularly hard work for 1 mark. But we are expecting questions at the end of the exercises or the sections to get more progressively complicated. Of the chickens expected to be the East Field after 3 days, what is the percentage of chickens that were also expected to be in the east field after both 1 day and 2 days? Right, so the first thing I did there was I worked out my chickens on each of the days. How did I do that? I basically took the transition matrix. I took this transition matrix and I multiplied it by 10,000, 10,000, 10,000, 10,000. All right, and I did it once, twice, and 3 times. Now, when I did that and only looked at the east field, what I ended up with was on day 1, there were 1,100. So 11,100 were in the east field. On day 2, there were 1,1297. And on day 3, there was 1,1293. Okay, so that's going to be a figure that becomes important later on. But of the chickens expected to be in the east field after 3 days, what is the percentage of the chickens that were expected to be in the east field after both 1 day and 2 days? Well, we know that at the start of this, after 1 day, there was 11,100 chickens. All right, what percentage of those stayed on into the east field? Well, if we go back here and go east to east, 28%. So we know of the chickens that were in east field on day 1, 28% of those will remain in the east field. And likewise, 28% of those chickens will stay in the east field on day 3. So those 11,100 times by 0.8 times by 0.8, which gives me 3163.16. All right, so let's say 3163 chickens, and it says of the chickens expected to be in the east field after 3 days, so we've got 3163. What is the percentage of chickens were also expected? Sorry, so those are the chickens that are expected to be in the east field after both 1 day and 2 days, and we know that there are 11292.8, and when I times that by 100 on my calculator, again, I'm not going to bore you with the data, you get 8%, which I'm 98% sure is the correct answer. At least that's the consensus for the people I had helping me work on it. Again, interesting question for only 1 mark. And if you can subscribe to my YouTube channel, that would be awesome. It just shows me that people are watching this, really. Right, networks and decision mathematics. I think this section was a lot easier. It was a lot nicer than that matrices section. But here we go. We've got Andrea, Ben, Kathy, Delaney, and Elliot are friends. I wish I had friends. They are visiting a theme park that has 6 attractions: carousel, a Ferris wheel, a mini coaster, a tilt wheel, a bump car, and a roller coaster. The following bipartite graph illustrates the attractions each friend planned to visit. Okay, thank you very much. Which friend plans to visit the most attractions? Oh, well, hopefully you will notice that Andrea's doing 1, Ben wants to go to 3, Kathy's 1, Delaney to 2, Elliot to 2. So I'm going to go Ben. Nice, simple question to start with. Thank you, Ben. How many attractions have only 1 friend planning to visit? Well, that's really saying how many attractions have only got 1 line coming into it. Well, Ferris wheel. Let's try again. Carousel, the Ferris wheel, and the tilt-a-wheel. There we go. So again, nice question to start with. 3. When the friends arrive at the theme park, there is only time for each friend to visit one of the attractions that they planned to visit. If the minimum number of different attractions are visited, list the names of the attractions. Oh, the minimum number. Okay. So what I did here was say, well, Andrea. So what do we got? Andrea, Ben, Kathy, Delaney, and Elliot. So Andrea only wants to visit the Ferris wheel. So what I did was I said, well, okay, there's a Ferris wheel. And Ben wanted to go and visit the carousel, the mini coaster, and the bumper cars. Now, again, if you've got the paper in front of you, that will be easier, but all I'm doing is reading off. Kathy wanted to do the bumper cars. And Delaney wanted to do the M mini coaster and the R, which was roller coaster, and E wanted to do the tilt-a-wheel and the roller coaster. So what I'm trying to do is find the rides that there are most of, effectively. And so it's clear that there are roller coasters, so it would make sense for both D and E to go to the roller coaster. we would make sense, therefore, for B and C to do B, which was the bumper cars, and A can only do F. So in which case, the minimum number of different attractions would be 3, and we want to list the names of those. So we would write Ferris wheel, bumper cars, and roller coaster. There we go. 1 mark. The theme park entrance, roller coaster, whatever else, are represented by the vertices in a graph below. The edges on the graph represent the paths within the theme park. The number on each end represents the length in meters of each path. Okay, Rowan works for the theme park collecting money from the ticket booths at each of the attractions. To do this, he visits each attraction once, starting and finishing at the entrance. All right, so he's going to visit the attractions once. So that basically means he's going to meet and go to each of the vertices only once. He's starting and finishing the same place. What is the mathematical term to describe that? Are you all shouting at me? Hopefully not. Hamiltonian cycle. There you go, Hamiltonian cycle. Write down one possible route that Rowan could take, all right? So me, I went E, M, C. So E, M, C, R, F, T, B, E. All right, so that was the route that seemed to be the most logical to me. So I got E to M to C to R to F to T to B and to E. There we go, 1 mark. Nice, easy question. An inspector is called to check all the paths in the theme park, and the inspector would like to travel a route that travels along all the paths only once, starting at the entrance. Okay, now we're back to path. So if we're doing path is Euler, with reference to the degrees of the vertices on the graph on page 22. Well, we haven't done the degrees at the moment, so let's do that. So it's got 3, 2, 2, 3, 4, 3, and 3. There we go. So those are the degrees all right. Explain why the inspector is not able to route. So what we're really saying here is it's an Eulerian trail, all right? Why can't we do an Eulerian trail? Because that's what it's called to go from the what does it say? Like to walk a route traveling or starting at the entrance. It doesn't say it's got to finish at the entrance, it's got to start at the entrance. And to do that, it's got to have 2 vertices with an odd degree. Well, it doesn't. It's got way more vertices with an odd degree. It's got 4, so that's why it can't be. And there we go. So an Eulerian trail is not possible as there are more than 2 vertices with an odd degree. You must have 0 or 2 vertices for an inspector to complete this route, right? Because again, although it doesn't say that it can not finish at the entrance, it is possible here, right? The inspector decides that the path between the bumper cars and the tilted wheel needs to be closed for maintenance. Rowan will need to collect money from the ticket booths at each of the attractions, starting and finishing at the entrance. To do this, Rowan may need to visit 1 or more attractions twice. If Rowan visits each attraction, starting and finishing at the entrance, okay, that's important, starting and finishing at the entrance, what is the length of the shortest path Rowan can take? So many people, and me included, turn around and go, what on earth is this question all about? Is there an algorithm? And I, to this day, do not know, is there an algorithm? I haven't found one. And if you have one, please leave a comment below and let me know. But what I decided was, when I did this, was to get to R, we have to go along here and we have to go along here. Once I'm at F, I've really got no choice but to go that way. And then I've got to get back to E. So the question really comes down to, do I go E to M to B and back, or E to B, B to C, and C to M? Now, what happens is if you do the 47 plus 33 plus 35 plus 35, I think you get something like 150. If you do 37, 35, 33 and back, you actually get a much smaller value. And as such, the correct answer is actually that there, all right? So to be able to do this, you are going to walk 37, 35, 33, and then back 33, 55, 51, 62, and 65. And when you add all those together, you get 371, whatever the units are. I don't even know what the units are. 371. Job done. Okay, and again, if you've got an algorithm that can do that absolutely every single time, please let me know, okay? Right, a tilt-a-whirl attraction is being upgraded. It will close for the duration of the upgrade. Oh, by the way, probably what I should have said, if you remember, is that this here was crossed through, which is why you couldn't actually go that way as well. Right, last question. Love these questions. All right, the tilt-a-whirl attraction is being upgraded. It'll be closed for the duration of the upgrade. The upgrade involves 12 activities A to L. The directed network below shows the activities and completion times. Oh my goodness, I'm feeling a crashing question coming along. But let's go. Right, list the activities that exactly have one immediate predecessor. All right, one immediate predecessor means that only one line is going in. So C only has one line going in. What else? J only has one thing going into the dot. And that's what I'm saying. There's only one line going into that dot. So C has an immediate predecessor. There's only one line going into there. It's got an immediate predecessor. What about anything else? Hold on. There's only one line going into that dot there, which would suggest that both D and E also have one immediate predecessor. And these type of questions have tripped me up so often, it becomes really, really irritating. But it is C, D, E, and J. Thank you. What is the minimum completion time of the tilt-a-whirl? Sorry, what is the minimum number of days the tilt-a-whirl will need to be closed to complete the project? Oh my goodness, I said project. I've become Australian. Well, what we do now is we draw these really, really time-consuming boxes. Now, while I'm drawing these, I'm going to say now, I've just done a SAC with my students, and I have said over and over and over and over and over again, you get what I'm saying here, do not do not do the forward and backward scanning on the nodes. Don't do it on the nodes, do it on the edges. I've never yet got a float time question wrong, right? 3 of my kids basically ignored me, did it on the vertices and didn't get any of the float questions right. I don't know why it doesn't work for me. Maybe it's something I'm doing, but this always works on the edges. So let's work it through. A has a 0 and a 0 because it's starting. I now do 0 plus the 5 would suggest that my earlier start time of C is 5. I'm going to do B is 5. So 0 plus the 5 must mean that D starts at 5, as does E start at 5. All right, so 5 plus 6, and what I'm saying here is 5 is where it starts, plus the 6 gives me 11. I'm going to write 11 there. The reason being is I've got a choice coming into that node. 5 plus 7 is 12, so I now know that that's got to be a 12. So anything that's coming out of that node has got to be a 12. So that's a 12, and that's a 12. He says, mistakenly deleting that box. And so is F a 12 as well. Right, I've got a choice coming into this one here. So 12 plus 3 is 15. 5 plus 5 is 10. So that must be 15. We have a choice coming in again here. So 12 plus 3 is 15. 15 plus 4 is 19. So K must be 19. We've got 12 plus 4 gives me 16. 16 plus 6 gives me 22. 19 plus 5 gives me 24. I've got that choice. Got to choose the biggest, which is 24. And that's going to be 26. So there we go. I can now go to here because I've done my forward scanning and say, right, well, in which case it's going to be 26 days. What is the latest start time in days for activity I? I've now got a backward scan. All right, well, again, this takes practice. And if you can't do it, then please practice. There are so many marks for these type of questions that if you get this right, you will smash this, okay? And if you haven't subscribed to my YouTube channel, if you could do that, it would be awesome, all right? Again, nobody watches my math content, really. And the people who do go, oh my God, it's amazing. If you are looking for a downloadable summary book because yours isn't looking particularly great, head over to maffsguru.com, and there, for a very small fee, there is a summary book already there made for you with VCAA questions and notes and all sorts of stuff on it that I've created to try and help. All right, now let's go back to this backwards scanning. Let's do it in green. That's going to be 26. Right, so 26 minus 2 gives me the 24. 24 minus 6 gives me 18, and 24 minus 5 gives me my 19. All right, the only places I'm interested at the moment is there because there's a choice, and there because there's a choice. So I've got 18 minus 4 gives me 14. What have I got here? I've got 19. Oh, I've tried to do it again. 19 minus 3 gives me 16, and 19 minus 4 gives me the 15. I know that I'm in the right line so far because I've got numbers that are matching up. Right, where are we? So I've got 15 minus 3 gives me 12. And I've got 15 minus 5 gives me 10. All right, so now I've got a choice at this node here. I've got 14, I've got 16, and I've got 12. So I have to use the smallest, which is 12. 12 minus 6 gives me 6 in that one there. I'm still at 12, all right, because I've got my 12 at this point here. Minus the 7 gives me 5. All right, again, I've got a choice. I've got 5 coming into there and 10, so use the smallest. 5 minus 5 is 0. And 6 minus 5 gives me 1. So there we are. As far as I'm concerned, that is my forwards and backwards scanning. What is the latest start time in activity for I? If I look at I, it is 14. All right, and again, so that's basically reading off the value of this box here. And if you didn't forward and backward scan, it's nigh impossible to be able to do that. So that's 14 days writing in green. Which activity has the longest float time? So again, without being able to do this process, you would never realize that the longest float time is in fact that one there. All right, so E, and it just simply wanted E. It didn't want the length of it. It's just E. The management of the theme park decides that the Tilt-A-Whirl attraction will be closed for too long to complete this project. They give the project manager a budget to reduce the overall completion time represented in the table below. Each of the activities can be reduced by a maximum of 2 days. There we go. We got that values there. Complete the table below showing the reductions in individual activity times that would achieve the maximum reduction. Now, what I'm actually going to do is write down the answer, because I know some of you will be like, well, no, I just want to check I got it right. Others of you will want to be like, well, can you show me the process? And I will obviously do my best. But the correct answer is 2, 2, 1, 0, 2, and 0. Now, if you are quitting there, thanks for watching. Subscribe to my YouTube channel. That would be awesome. All right. Like the video, spread it around, tell people it's there, because I actually generally want it to help. But what you've got to notice, for those of you who are still sticking with me, is you've got to do it for the minimum cost. Okay. So the way to do this is to come up with all the routes through the network. And there are 7 of them, believe it or not. And so the routes are A, oops, let's try that one again. You've got A to C to I to J to L. You've got A to C to H to K to L. You've got A to C to F to G to K to L. And all I'm doing here, he says, is working through each of my routes systematically. So that was my first one. My next one was this, coming down here up there. My next one was this one. Okay. So got 1, 2, 3. Why have I got too many routes? Oh no, there's my 3. Okay. Oh God, I'm losing the plot already. Where's my next one? B to D to I to J to L, B to E to G to K to L. 1, 2, 3, 4, 5. I'm sure there's more. Yep. B to D to F to G to K to L. And there's B to D to H to K to L. So those are my 7 routes. 1, 2, 3, 4, 5, 6, 7. Now what I do is I write on the completion time for each of those in a different number. So A is 5. B is 5. And I'm just reading these off the diagram. C is 6. So anywhere I see a C, I'm writing 6. D is, what is D? 7. E is 5. F is, where's F? 3. G is 4. H is 3. What else? G, H, I is 4. It's 4. J is 6. Have we got all my J's? Yep. K is 5. And L is 2. Now, the reason I'm writing all these on is because it helps me crash a little bit later on. So what I'm now going to say is work out all my individual routes. So I'm going to add all of these values together to work out what my paths are. So 11, 15, 21, 23. So that then has a completion time of 23, 11, 12, 13, 14, 19, 21. What's this one going to be? 11, 14, 18, 25. This is going to be 7, 8, 9, 10, 7, 8, 9, 10, 11, 12, 18, 24, 10, 15, 19, 21, 5, 12, 15, 19, 24, and finally we got 5, oh sheesh, what I got, 5, 7 is 12, 15, 20, 22. Hopefully those are therefore going to be my right values. Apparently I can't add up. So 12, 13, 14, 15, 20 are 26. Okay, glad I checked that. Now, having done that, I'm now going to look to crash. Now, to do this, I'm actually going to do something that's easy for me to do, not so easy for you guys to do. And I'm going to resize this just to make it, I'll try again. I'm going to resize this just so I've got a little bit more room for working. Now, I've got to crash in the cheapest possible way, all right? So I'm going to crash the ones I can. And so I tend to highlight now A, B, D, E, right, E, G, and H. All right, so those are the ones I can crash. Hopefully I've got all those. Yeah, okay. So those are the only ones I can crash, and I'm going to start cheaply. My cheapest one is E. Is there any point in doing E at this moment in time? No, because the only path that's got E in is that one there. If I reduce this, I'm not interested because, well, basically that's not going to change to 26. And every time I crash, I take one down at a time. I don't try and do 2 or 3 because it goes horribly wrong if you do. So what's the next one? What's my next one? G, 1500. Right, I'm going to take G down. The reason I'm going to take G down is because that 26 is the one I want to do. So I'm going to take 1 off of G. And I'm going to say, well, therefore that now becomes 25. And anything with a G in it, I'm going to take a number off. That becomes 20. And that becomes 24. Okay, right. So can I crash again? Yes, G can crash again because 25 is my biggest number. I'm going to crash G one more time. So that means anything with a G, and I'm going to take another one off. That's going to give me 23, 19, and 24. Now, I can't crash G anymore. It's exhausted, all right? So that's my 2 done for G. What's my next one? Well, actually, probably H. I should have probably looked at H. Now, the reason I'm not going to bother with H at this moment in time is, once again, that was my highest number. H is on this path here. H is on that path there. There's no point doing H. So let's see. What's my E? Can I crash E at this moment in time? Nope, because that's 19. That's 24. So I'm trying to look for something on the cheapest between B, D, and G. B is 2,000, D is 2,500, and I can't have G anymore. So I'm going to put a line through that because I can't do G anymore. Okay, so B, 2,000. And what was the other one? D, 2,500. So I'm going to do B next. Crash B by 1. So anything with a B now gets crashed. That's 21. That's 23. That becomes 18. That becomes 23. There we go. So B down by 1. Can I reduce B again? Well, now we've got a problem because I can't do... If I change B, that 23 will go down, but that one won't. So I've got to try something now that matches up between this and this. Is there any value that joins? Yes, G, but I've actually exhausted G. So I'm going to cross through all the G's to say I can't do those anymore. Oh, shucks. All right, well, okay, we can't do 1. There's nothing that matches here because I've only got an A on that one there, and I've only got a B and a D on that one there. So actually, as it turns out, because A and B are both $2,000, I'm going to take 1 off of A and 1 off of B. So 1 off of A gives me 22. 1 off of A there gives me 20. 1 off of A gives me 22. 1 off of B gives me 22. 1 off of B gives me 17. 1 off of B gives me 22. 1 off of B gives me 20. Now, again, what we've got to do is 1 at a time. And every time I do this, I'm now looking and saying we've got a 22, a 22, a 22, a 22. So now I've got to look again. What is on this path, this path, this path, and this path that I can reduce? Well, I can reduce an A by 1. Okay, so that's certainly going to help me there. But reducing an A isn't going to help me with these two paths here. So what do I have to reduce there? Well, my next cheapest would be D, because I've got no B's left. So I'm going to reduce A by 1. So that's going to give me 21. That's going to give me 19. And that's going to give me 21. So there's my A. And I'm going to do a D. So a D is going to give me 21, 21, and 19. And then basically, that's it. I can't go any cheaper because there's nothing else I can crash because I'm pretty much now exhausted my A's. I've exhausted my B's. I've exhausted my G's. I've only got one D left, but it's not going to help me reduce anything on this path and this path. And so that's how I know I'm done. So 221020 gives me my correct answer. And doing that, working out and doing it one at a time really does make life so much easier. And I'm pretty sure that that's the end of the paper. Hopefully you have found it stimulating and useful and entertaining and all those type of strange words. Subscribe if you can, tell your mates if you can, tell your teachers if you can that there's Maths Guru out there. Go over, sign up. It's got all the videos there for revision. And if you're just starting out a revision, I'm sure it'll be useful. Otherwise, wishing you the very best for your exams. And hopefully I'll see you in some more videos. But for now, take care. Goodbye.